Number 1, we have the center frequency. To solve for the center frequency, we have the formula square root of f minimum times f maximum. For the f minimum, we have the 30 MHz and 300 MHz for f maximum. With that, the total center frequency will be 94868329.81 Hz. Number 2, we have the wavelength. To solve for the wavelength, we have the formula 3 times 10 raised to 8 meters per second divided by the center frequency. And the total wavelength will be 3.162277766 meters. Number 3, we have the length of driven element, in short, LDE. For the LDE, we have the formula wavelength divided by 2. So that will be 3.162277766 meters divided by 2. So the total LDE will be 1.58113883 meters.
Let's discuss from number 4 to 6. Number 4, length of director. In this, we did LD equals to LDE minus 5% LDE. So you replace the LDE to 0.95. And you replace the 5% LDE to 1.58113883 meters. And we did 0.95 times 1.58113883 meters is equals to 1.502081889 meters. Length of director. LD1, LD2, LD3. These three are the same with 1.502081889 meters. In length of reflector, we did LR equals to LDE plus 5% LDE. We replace the LDE to 1.05 and we replace the 5% LDE to 1.58113883 meters. And we times them both, so it is equals to 1.660195772 meters. And number 6, we did SR minus DE 0.15 times lambda. This is the spacing from reflector of driven element, SR minus DE. And we times them both as we replace the lambda to 3.1622766 meters. So it is equals to 0.4743416449 meters.
Number 7. In order to get the value of SDED1, we need to multiply 0.1 times the wavelength. Multiply both, then you will get 0.3162277766 meters. That will be the value of SDE to D1. Number 8. Spacing from SD1 to SD2, then SD2 to SD3. The formula will be SDE minus D all over 2. So 0.3162277766 meters divided by 2. You will get 0.158113888 meters. That will be the same from SD2 to SD3. So number 9, the length of boom. We need the value of spacing from reflector to driven element plus the spacing from driven element to directors plus SD1 to SD2 plus SD2 to D3 plus 1 inch. Add all, then multiply to 0.0254 meters times 2. So the length of boom will be 1.157597181 meters.
So good day, I'm going to discuss about the scale diagram of our antenna. On the left side of the antenna, we have the length of reflectors, which is equals to 1.660195772 meters, which are the computed length for the reflector. Next is the length of the driven element equals to 1.581138883 meters, which are the computed length for the driven element. And next is the length of directors is equals to 1.502081889 meters, which are the length of driven director 1. We know that the director 1, 2, and 3 are all equal. So next is the length of boom, which is equals to 1.157597181 meters, which are the computed length of the whole antenna.
Sa nakikita niyo po dito sa right side ng diagram, sa una po, ito po yung yung alam sa kabilang dulo ng antenna, yung 0.0254 meters. And sunod naman po, ang total po na nakuha namin sa reflector to driven element 0.47434169 meters. And next po, driven element to directors, ang suot na nakuha namin 0.31622777 66 meters. Ano po yung total na nakuha namin. Sa directors naman po, ang measure din po namin na nakuha dun sa ano po, para-parehas ay 0.1 58113883 meters. And para-parehas po sila nung directors na yun, yung 1, 2, 3. Yung